Okay, so good evening. I think I'm recording na. I think the electric fan won't be as loud as this time. Might think, or I hope. So ano tayo ngayon? Chemistry tayo ngayon. We're talking about gas stoichiometry this time. So if you can remember in stoichiometry, ang pinagko-compare natin is yung ano, ang pinagko-compare natin is yung mole to mass ratio, the mass to mass ratio, and the ano, so mole to mole, mole to mass, and mass to mass ratio. And dito naman sa ano, sa gas stoichiometry, it's practically the same but with changed values. So, ang meron tayo na conservation dito is your volume to your mass. Okay? And then we also have mass to volume. And we also have volume to volume. So, i-cover natin muna itong dalawang to. In this time, itong dalawang. The volume to mass and the mass to volume conservation in gas stoichiometry. So, what we're basically looking for dito is yung volume, the space na nagte-take up sa isang gas in liters. And yung mass naman is in grams. Kapag gusto mo siya i-convert sa liters, which is your volume, gamitin mo yung isang familiar equation which we have all familiarized with, which is the ano, your ideal gas law, which is your PV is equal to your nRT. P for pressure, V is for volume, N is the number of moles, R is your gas constant, and your T is your temperature in Kelvin. Okay? So, para mas maintindihan natin yung mga concept, uh, I think we should go over some problems muna. Okay? So, dito tayo sa unang problem. Using the following equation, calcium carbonate in solid state is produces um, carbon dioxide and calcium oxide. So, ano pala yan? Hindi siya nagpo-produce. It's basically decomposition. Dahil nga, itong ano, wait, my apologies. Ito, itong calcium carbonate, it is the supposed product. But what we do know is your reactant produces your product. Likewise, your product can decompose into your reactant. Ganito ng R. Because your product can produce your R as well. So I think na ano naman yung concept dito. So nag-decompose yung calcium carbonate into carbon dioxide and calcium oxide. So the first thing we need to do is to analyze if balanced na ba. If the equation is balanced. So we have one calcium on both sides. We also have one carbon, and I think we have 3 oxygen on each side. Right? So let me read the problem again. And using the following equation, calcium carbonate produces or decomposes into carbon dioxide and calcium oxide. Determine how many grams of calcium carbonate will form from 3.45 liters of carbon dioxide. Assume their action is done at 180 m and 298 Kelvin. So, ang hinahanap natin dito is yung grams. Ng calcium carbonate. Itong CaCO3. Yun yung hinahanap natin na value. At ang given sa atin is yung volume. This is considered as the mass. This is in this is considered as the mass of ano. So ano to? It's a volume to mass relationship, conservation, whatever you call it. It's a volume to mass relationship or ratio. So ang gusto mo munang gawin is you may want to find the moles of carbon dioxide. How do we do that? So, gaya ng sinabi, we're gonna use the ideal gas law for this. Is your PV is equal to your RT. Ang hinahanap natin yung moles, which is your N. Hinahanap natin yan para sa carbon dioxide. This is the first step. So, let's highlight that in red. Okay. So our pressure is 1 atm. Let's put that 1 atm. And our volume is 3.45. Equal yan sa N times your gas constant. Nangauli ang gas constant if the value is liter atm per mole Kelvin, it's 0.0821. I think I'm messing up something here. Let's tone it down. And your temperature is 298 Kelvin. Okay. So this is just 3.45. And then you may want to solve for this. So let me grab my calculator here. 0.0821 times 298 is equal to 24.4658. Yan. And then yung N dito, because we also multiply that by N. Sorry, this is your N. Okay. And now what you want to do is divide both sides by this value, 4658. Same by the side to find the number of moles. Yan. Tapos kakancel mo to. This will cancel. And now we divide this quantity is 3.45 divided by 24.4658. So that's approximately N approximately 0.14. So ito na yung magiging ito na yung number of moles because that is N. So you will have 0.14 moles of ba hinahanap natin? This is carbon dioxide. 0.14 moles of carbon dioxide. So yan yung first step. Natin. And then the next step is we will convert that to the moles of calcium carbonate. So balik tayo sa stoichiometry, basic stoichiometry. Barin na natin to. So I'm pretty sure you can just watch it. Just bear with me. So I know that I have 0.14 moles. Oh, sorry. 0.14 moles of carbon dioxide. So, tingnan natin yung ratio. For every 1 mole of carbon dioxide, there is also 1 mole of calcium carbonate. So, lagay natin yun dito. Dito sa taas yung calcium carbonate. And this is also mole of CO2. Okay? So, it's basically just, cancel both sides. Anything multiplied by 1 is the same. So, kapag may 0.14 moles ka of carbon dioxide, meron ka ding 0.14 moles of calcium carbonate. So, ayusin natin. Yan. So, ang final step naman ngayon is we're gonna convert this mole to grams of calcium carbonate. Okay? So, ang gagawin dito is you need to find the molar mass of calcium carbonate. So, calcium, if I remember, I think it has atomic mass of 40 plus your carbon, which is 12, and then oxygen, which is 16. 16 times 3 is 48. So 40 plus 12 plus 48 is equal to 100. So barin muna natin to. Ito lang. This, that. So 0.14 moles. Moles of calcium carbonate is meron kang 100 grams of calcium carbonate for every 1 mole of calcium carbonate, or CaCO3. So cancel. So 0.14 times 100 is just 14. So ito natin dito, 14 grams of calcium carbonate, and let's box that. So we can say that there would be approximately 14 grams of calcium carbonate that will form from 3.45 liters of carbon dioxide when their action is done at 1 atmosphere and 298 Kelvin. So ito na yung final answer natin. Yan. Okay? So I hope you got something from that. So that is your volume to mass conservation or ratio in gas stoichiometry. I think we have some more problems here. Yan. Ito, mas mahirap. It involves some analyzing this time. Okay? So, if 45 liters of methane undergoes complete combustion at 730 millimeters of mercury and 20 degrees Celsius, how many grams of water is formed? So, nakita natin, parang, nasan yung equation? There is no chemical equation. But we see this, complete combustion. Oh, sorry. My apologies. Nakita natin tong complete combustion. What is the equation for complete combustion? So, if I recall correctly, ano yan? We have, ilagay mo natin yung skeleton equation. So, basically, kapag ano yan, combustion, involves some gases. For this time, it's particularly, it can be any gas. No. The CH gases is ano, what's mostly involved in combustion. Like you have methane, which is present here, and you can have propane, butane, and much more. But in this case, it's methane. CH4 plus you have oxygen gas, which will form carbon dioxide and water. And we also have energy. We also have energy. Yes. But we will disregard that. Lagay lang natin dahil ito yung equation talaga. So, um, might I ask you, is the equation balanced? No. Yes. No. Okay. It's not balanced. Because if you look here, bigyan muna natin yung mga important terms. And then this. So we have 1 carbon, 4 hydrogen, and 2 oxygen. Over on this side, we still have 1 carbon, and then we have 2 hydrogen and 4 oxygen. So, basing on this side, kailangan natin ng dito muna tayo mag-base. Let's base it from here. Let's base it from that side. Kailangan natin ng 4 oxygen. Okay? So, actually my bad. I think that's 3. That's 3 oxygen. If I'm not mistaken. So, let's base it from this side. Kailangan muna natin ng 4 hydrogen. So, let's base it from this side na. Sorry, that was my mistake. Let's base it from that side. So, para magkaroon ako ng 4 hydrogen, I think I need to put a 2 here. Yan. Ilagay ako ng 2 dyan. Para siya maging 4. Likewise, this will be, this will be 4 as well. And so, because I need 4 oxygen now, lalagay din ako ng 2 dito. Because 4 divided by 2 is 2. Oh, sorry. 2. So, this will make it 4 as well. So, do I have a balanced equation now? 3. Yes? Okay. So, I think we can proceed. We can proceed now. With this, let's just erase this first. We can proceed with the problem now. Let's just keep that energy in there. So we have 45 liters of methane. So I think it's the same process. I-convert muna natin itong mga terms na to in the terms we need, because we need atmospheres and Kelvin. So sa 733 millimeters of mercury, ano yan, 1 torr is equal to 1 millimeter of mercury, and 1 atm is equal to 760 millimeters of mercury. So parang sinabi na rin natin na it could be torr as well, diba? So basing on this information, I have actually 700 and, 730. So, if you wanna base it on the Tor, well, yan din yung pagbabasahan nyo. But in this case, mas madali. Ano na din yan, yung millimeters per mercury. So, I don't know why I did that. So, just so you know. For 1 ATM, there is 760 millimeters per mercury. Okay, hindi mo siya kasha. Let's just cancel. Well, 760 divided by 730. Actually, 730 divided by 760. So that's approximately 0.96 ATM. So, yun na lang yung pagbasahin natin. It's just an approximation. Okay? So, and for the degrees Celsius, we just add 273 to convert it to Kelvin. So, it's just 293 Kelvin. Okay, so I think we can proceed yet again. So this time, we will use the ideal gas law formula again. So let's write it down. PV. We're finding the moles again. We're finding the moles, so let's highlight that in red. RT. So our pressure, like I said, it's 0.96 ATM, and then ang ating volume is 45 liters equals to your N. Dalang nahanap natin is the number of moles of methane para mai-convert natin siya sa sunod pang mga values. And alagyan na nga natin pala yung values. That is 0.0821, and your temperature in Kelvin ay 293. Am I right? Yes. So, dito mo tayo simula. 0.96 times 45. So, you have 43.2. That's the point. Okay. So, 0.0821 times 293. So, meron tayong 24.5 0.0553, and don't forget your N because we're solving for that. So again, divide both sides by N. 24.0. So, and then you can just cancel that. So 43.2 divided by 24.0553 is let's just say let's make an approximation. It's approximately 1.80. It's approximately 1.80. Let's make that 1.80. moles of methane. Ano ba siya? Yes, it's methane. So, kung natin yung number of moles, then we can proceed with the other steps of the problem. So, yan, nakita nyo na. Pwede ko na burahin. Actually, before we move on, so you might be wondering why I'm just solving for the actual value instead of deriving the formula. So, ano naman, kapag halimbawa, PV equals nRT, hinahanap mo yung N, how will you do, paano mo siya hanapan? Then, if you wanna derive the formula, this is just RT on both sides. It's basically the same. Ganun din yung kinahahantungan. Parang shortcut lang yung ginawa ko. So, ito yung formula mo, friend. It's, your N is equal to PV over your RT. Yung ginawa ko yung parang diniretso na. But you can do this as well if gusto mo. I'm not stopping you in that. Just a quick heads up. Okay. Just a little clarification on my side. So, meron na tayong 1.80 moles of methane. Ito niya, no, baka malito pa kayo. It's H2O. So, 1.80 moles of methane. I-ratio natin siya sa moles of H2O. So, we're converting it. It's stoichiometry all over again. So, sa every 1 mole of methane ay merong 2 moles of water. Okay? So, lagay natin dito. 2H2O over your 1 mole. Okay. Kulang pala. Mali pa. 1 mole of methane is equal to your 2 mole of water. So, cancel both sides. So, 1.80 times 2 is just 3.60. Am I right? It's 3.60 moles. 3.60 moles of H2O. So, ngayon, we're on the final step na. We're gonna convert that to the grams of water. Okay? Again, get the atomic mass. The molar mass rather of water. So hydrogen is 1. There's 2 of those times by multiply that by 2, we get 2. And the atomic mass of oxygen is 16. So we add 16 to that. So we have 18 grams of H2O. Kada isang mole ng H2O. Anyway, put this one. Okay, so that. So what do we get? So we get approximately burin na natin dahil may sagot na naman tayo. So the answer to that equation is this. Ito. We have 64.8 grams of H2O. This would be our final answer. Okay? So, you can interpret that by saying that 64.8 grams of H2O is formed when babasahin mo lang to 45 liters of methane undergo complete combustion at 730 rather millimeters per mercury and 20 degrees Celsius. This is your final answer. Okay? Again, this is a volume to mass relationship. And again, like I said, bibigyan pa natin focus ay itong mass to volume relationship, which can be found in this problem. Okay. So, panibagong problem na naman. Let's read it muna. Let's analyze the problem. So, 2 moles of chlorine gas reacts with what is that? That is, I think, acetylene, C2H2, to produce C2H2Cl4, which is, I think, your tetrachloroethane. Okay. How many liters of chlorine will be needed to make 75 grams of tetrachloroethane? Assume the reaction is done at 1 atmosphere and 298 Kelvin. So ngayon, ano napansin niyo? It's it's a different type of problem na. This is what we call the mass to volume relationship or ratio, however you want to call it or address it. So I assume the equation is already balanced na. Yes, it's balanced na. What you want to do first is convert muna natin yung grams of tetrachloroethane into its moles. Okay? Into its moles. So 75 grams of C2H2Cl4. So let's get the molar mass of tetrachloroethane. So carbon is 12, it has a mass of 12 times 2, which is 24, plus hydrogen, which has an atomic mass of 1 times 2. Then you have, of course, 2, and then chlorine, which has an approximate i-approximate na natin yung kanyang atomic mass into 35. But for the sake of it, let's actually write down the yung mismong mass, which is 35.45. So plus 35.45 times 4. So altogether, you have 167.8 grams of C2H2 your tetrachloroethane for every mole of that. 1 mole of tetrachloroethane. Yes. So again, likewise, you just want to cancel this out. Cancel mo yan. So i-divide mo na lang. So 75 divided by 167.8. So that's that is ang lumabas sa sagot 0.446960667, but let's approximate it into 0.45 moles of your tetrachloroethane. Yan. Ngayon, i-ano na natin siya. I-convert sa moles ng, ito, ng chlorine. Yun yung hinahanap natin. And so, yan. So, tingnan natin sa ratio. For every 1 mole of tetrachloroethane, merong 2 moles of chlorine gas. So, dito yan. Pagkasya na natin. 2 moles of CO2 ay ang meron sa 1 mole of sa 1 mole of C2H2CO4. Ano siya kasya? H2CO4. Ganun na lang. So, again, cancel that. So, 0.45 times 2 is just 0.90. 0.90. So, meron kang 0.90 moles of chlorine gas sa 75 grams of tetrachloroethane. Dahil dun sa nagsimula. So, yan. Yan yung ipa-plug in natin sa ideal gas law equation. Okay? Liburin na natin to. We will solve now for the ano ba? Yung volume in liters. Okay. So, i-convert na natin siya. So, we're looking for your volume. We can specify that by the formula is your nRT over your P. So, ganoon na lang. Gagawin na lang natin. Guys, sige. Let's do that. But the other way to do it is you can solve it algebraically. But in this case, gawin natin yung formula na yan. So, V is equal to your N. The number of moles, remember, yung nasolve natin, 0.90. That is the mole of chlorine gas. Then, yung gas constant mo, 0.0821 times your temperature, which is 298 over 1. Kung natin salo yan, dahil di-divide lang by 1, it's just by 1. Let's just erase it. Actually, no. Baka malito pa. So, solve natin. So, 0.90 times 0.0821 is 0.07389. Now, multiply that to 298. So, we have 22.01, or we can just approximate that to 22. So, our volume in liters is 22 liters of chlorine gas. Yan. Yan yung hinahanap natin chlorine gas. Am I right? Yes. So, yun na yung final answer. Yan. So, that's just an approximation. Dahil nakikita pa nga dito yung iba sagot minsan is 21.8 something. But this answer is close as well to that. So, yan yung mass to volume relationship. Ito namang itong volume to volume, madali lang yan. Because you're going to assume yung moles, i-assume mo na yun yung liters. Yan na yung volume. So, just to give a brief example. Paano ba? Let's say, for sa this equation. I-assume natin tong, kuha natin to. Saan ba dito yung madali? Yan. I-assume natin yan. Brand na natin muna. Ito ay volume to volume relationship. Conservation. I-assume na may equation kang ganun. Yan. Yung calcium carbonate. Assume na meron kang 10 liters of calcium carbonate. Ilang liters of calcium oxide yung mapoproduce niyan. So, like I said, assume that the moles are the liters. So, bigyan natin siya na let your mole be your liter. Yan ay sa volume to volume relationship. Yan. So, simple lang. So, ko ditong 1 liter of calcium oxide over your itong 1 liter of calcium carbonate. So it's just 10 times 1. So if you have 10 liters of calcium carbonate, then you will produce bigyan na nga natin dito. You will produce 10 liters also of calcium oxide. Paksa natin just to find our answer. Okay. So I guess that wraps it up for gas stoichiometry and these types of the relationships, and also how to utilize the ideal gas law into solving these types of equations. So I hope you learned something naman. So I've been here for over 43 minutes now. So yan, I hope you've learned at least kahit katiting man sa mga pinagsasabi ko dito. And yeah, so that's that, and I guess I'll see you next time.